All right, everybody, Mr. Dean here. Today we're talking about trig functions of any angle. So far we've studied the unit circle. So in those angles, the radius of the circle was 1. So the hypotenuse of your R value was 1. And you go around the unit circle, around the edge, and we landed at a spot. So if the angle was 135 degrees, that spot had an x and a y value. We looked it up, um, or we computed it using a ruler along the x and y axis. So if we did using the ruler, it would be negative zero point 0.7, comma positive zero point 0.7. And if we just went on to the unit circle that we were given, we have more exact values, but these are the same values as negative zero point 0.7 and zero point 0.7. It's negative root 2 over 2 and positive root 2 over 2. So those are the values. Then we talked about sine and cosine in relation to that. We also talked about special triangles, and we memorized these two. You got to have these down. Across from 30 degrees is the 1/2. Across from the 60 degrees is the root 3 over 2. And both of them have hypotenuses of 1. And across from 45 degrees, of course, the same on both legs, it's root 2 over 2. Memorize those immediately. Don't go any further. Write these down a couple of times from scratch. And if you can't get it all the way through easily, keep writing it down. One important notice we want to make sure that you understand is that you already memorized these probably in geometry. You might have memorized them with slightly different ratios than we are in pre-calc. In geometry, you might have memorized it with the hypotenuse of root 2 for not only the 45, 45, 90 triangles, but for the 30, 60, 90. You may have memorized it with the 30, 60, 90 with a root 3. For pre-calc, we're always memorizing it with the hypotenuse of 1. The ratios are all the same. It just makes a lot of sense in pre-calc, in trig especially, we divide by the hypotenuse so often, it makes makes our lives easier if we're dividing by 1. So if you've memorized the ones over here, well, they'll work. You can stick with it if you really had to, but most people eventually they succumb to the peer pressure and they memorize it with the hypotenuse of 1. Just makes your life easier. All right, so with the right triangles so far, 30, 60, 90, and 45, 45, 90, you'll be able to fill out the table of trig values up to about 90 degrees, okay? But once you get past 90 degrees, we don't have any right triangles that will fit the bill for any of these other angles, so it's time to expand. So, to show you how easy this is, I'm going to do these in my head right now. I have not memorized the unit circle all the way around. I've not memorized that table. But I do know the sine of 300 with just a little bit of thought is root 3 over 2, probably negative. Cosine of 315 is positive root 2 over 2. Sine of 150 degrees is a half. And sine of 270 is negative 1. That's how fast you'll be able to do these. You think about it, how did I do it so fast? Is he a wizard? Is he some kind of a magician? Not at all. The answer is all here in reference angles. It's all about reference angles. The reference angle is the angle formed between the terminal side of the angle and the x-axis. Extremely important that it's the x-axis, not the y-axis. So for example, if we had to find the cosine of 135 degrees here, we'd make a drawing, 135 degrees, and we have this little symbol in here, right there. It's called theta prime, all right? Theta prime. And if the x-axis forms a 180-degree line, theta prime in this case is 45 degrees. What I'll do is I'll extend the line always down to the x-axis, and that'll make a triangle. We'll call this then a 45, 45, 90-degree triangle. So we're using 45 degrees as a reference, and we're using this 45, 45, 90 triangle as a reference triangle. And we're going to call the hypotenuse 1. We're going to call then this side has to be root 2 over 2. Same with this side. And if we want to know the cosine of 135, we can still go back to our ideas of SOHCAHTOA. And we can also go back to our idea of that cosine is along the x-axis. And I have it as negative root 2 over 2. Now it's negative for a couple of reasons. One is that if you think about it as the x-axis, this cosine being the x-axis, and that coordinate way up here, that coordinate there, the x-coordinate of that is negative. Or if you just remember your shortcut that all students take calculus, it doesn't give you an explanation of why, but it tells you that only sine is positive in quadrant 2, so cosine must be negative. If we're over here and we're thinking about cosine of 11 pi over 6, of course that's in radians, a little scarier, but we have to draw the angle, we have to find that, however you want to find that. I think of it as being pi over 6 short of a full rotation, which would be 12 pi over 6, that'd be 2 pi. So 2 pi would be all the way around. I'm going to make my, this time we go up to the x-axis to make a reference triangle. And when we think about special triangles, at least in here, we don't do them in radians really, we do them in degrees. So this is a 30, 60, 90 triangle because that little missing portion, pi over 6, is equal to 30. We fill in our sides here carefully. Now I'm filling in the lengths of the triangle, so that's why the 1/2, I generally don't put in the negative because I'm thinking about lengths of a triangle. But if I think about the coordinate, again, the coordinate right there, then I have to think that it's a positive x and a negative y. All right? Either way, we're talking cosine here, so we're not concerned with the y-axis. Cosine of 11 pi over 6 is root 3 over 2, because cosine, again, is the x-coordinate. Moving down to sine, we'll do sine of 300. If there's no drawing given, we got to provide. So go all the way around. 300 degrees is 60 degrees short of 360, so 60 degrees is your reference angle. Across from 60 degrees in our special triangle is root 3 over 2. And just to fill in our hypotenuse and our other leg. And the sine of 300 degrees then, first I'll write root 3 over 2, but I need to remember that it's negative. Now how would you know that? Well, the shortcut is all students take calculus. But the real reason is because we're thinking of sine, which is the y-coordinate. And down here, if we were to remember doing this activity, we'd measure it out. Of course, on the y-axis there, you're down in negative world. So we got to make sure that our final answer is negative root 3 over 2. Tangent of 225. Draw another picture. Find 225. There you go. Draw up to the x-axis. Now again, be careful, never ever draw to the y-axis. Everything's going to be backwards if you do that. And we get in 225, I see that it's going to be a 45 degrees past 180. And so we have a 45, 45, 90. Our hypotenuse is always 1. Our sides are the same. 2 sides are the same. That's why it's got all those 2's in there. And the tangent of 225 is positive 1, because I'm really dividing a negative y-coordinate and dividing it by a negative x-coordinate. So negative divided by negative is a positive 1. The signs here, all students take calculus, all right? ASTC. It does not stand for the Association of Science Technology Centers. It does not stand for the American Society of Theater Consultants. We've been talking about it in that last slide. All students take calculus, and it's a shortcut for which trig functions are positive in that quadrant. So in quadrant 1, all the functions are positive. I also have it down here. All right, in quadrant 2, only sine and cosecant are positive. So sine and cosecant, they're reciprocals. You're always positive if your reciprocal is positive. All right, in quadrant 3, tangent is the only one that's positive because you're down in the negative, comma, negative quadrant. In other words, your x-coordinate and your y-coordinate are both negative. And when you divide them, because tangent is the y divided by x, you're going to get a positive. And then down in quadrant 4, the only positive trig function is cosine, and of course its reciprocal secant. So finding the trig of any angle is just a 2-step process, very easy. First, you find the reference angle, which remember is theta prime. And number 2, we just make sure before we're done that we determine whether it's positive or negative, simply depending on what quadrant it's in. All right, so remember this, going clockwise, all students take calculus. So some practical examples of this, find sine, cosine, tangent of this angle, theta. And we're not worried about what the actual angle is. We do know that its coordinate is 12 comma negative 5. So that means that this really isn't drawn to scale, but that's 12, and this side's positive 5 as a side of a triangle, but it's not a problem to put a negative there just to remind us that that y coordinate's negative. If you remember your Pythagorean triples, that is 13. We have a 5, 12, 13 triangle. And let's get to work. So the sine of theta is equal to, well, theta prime is in here, the reference angle, and we're going to use that idea. So from that viewpoint, sine is opposite over hypotenuse. And so we have negative 5 over 13. And we'll leave it like that as a fraction. Don't turn it to a decimal. It's a little cleaner as a fraction. Cosine is adjacent over hypotenuse. That is 12 thirteenths. And lastly, tangent theta is opposite over adjacent, and that is negative 5 twelfths. Notice that we never find out what theta is. It looks like it's about 300-ish degrees, but it doesn't really matter. We don't know what it is, and it's not asking us, so we move on. Example 2, we see examples like this a lot, where they're asking you, what quadrant, when they say where, what quadrant is cotangent theta positive, where's cotangent positive, and where's cosine negative? That's what that means, when cosine is less than 1. So I just draw out my 4 quadrants, and I'll actually write in A, S, T, C for which functions are positive in there. And I'm looking for where cotangent is positive. Well, cotangent's going to do whatever tangent does. Tangent is positive here, tangent's positive here, so we get rid of those two. Can't be in there. But there's an and, so it has to be also negative for cosine. So I look back at what's left. All of them are positive here, so cosine can't be negative there, so we're stuck in quadrant 3. So where is that true? In quadrant 3. Next example, evaluate cosecant of 5 pi over 3. All right, so we have to find 5 pi over 3. If you're still worrying about, converting it to degrees to try to find out where 5 pi over 3 is, remember our shortcut is that pi is 180 degrees, and first we'll divide by 3. So we'll take the 180, we'll divide first to get 60, and then we'll multiply that by 5. And you can see that we should draw our angle at about 300 degrees. All right, just a little shortcut that'll help us with our reference angle. There's 300 approximately, and we'll draw our reference triangle up there. So 60 degrees is our reference triangle, or inside of our reference angle, and it's a 30, 60, 90. We toss in the sides. That's why it's so important to memorize these. All right. And we need to evaluate the cosecant, which is the reciprocal of sine. So sine of theta is equal to opposite hypotenuse, so we're looking for, cosecant is going to be the hypotenuse over the opposite. So it's going to be 1 over root 3 over 2. All right, we have to fix that. 1 over root 3 over 2 is the same as 2 over root 3, and we'll rationalize that denominator by multiplying by root 3. And you're going to get 2 root 3 over 3. Now let's just make sure whether it's positive or negative. So all students take calculus. It is in the quadrant where cosine, C stands for cosine. Cosine's positive. Sine would have to be negative there. Sine, the y coordinate down here, is going to be negative. So cosecant's also going to be negative. So I need to toss on a negative here, not forget that. So we got negative 2 root 3 over 3. Next example, example 4, find cosecant theta if they tell you sine theta is negative 3/5. And they got to tell you one more piece of information. In this case, they tell you that the theta angle is in quadrant 4. So I just draw, I don't know what the angle is, I just draw some kind of angle in quadrant 4. Draw it nice and big, so you got sort of a triangle here that you can work with. And the sine of theta is always equal to opposite of hypotenuse, so if they tell us that it's -3/5. Let's use those numbers. And so the opposite side here will be -3, and the hypotenuse will be 5. And hopefully you recognize that it's a 3, 4, 5, or Pythagorean theorem will get you through that. And we're looking for the cosine of theta. Well, this is not going to be too hard. So the cosine of theta, once you have the triangle with all the sides in it, you're going to be all right. Cosine's adjacent over hypotenuse, and so we're looking at 4/5. Now, lastly, just make sure whether you're positive or negative. All students take calculus. Cosine is positive in quadrant 4. Because the x-coordinate is what the cosine is. That 4 is positive. And the hypotenuse is always positive. A good note. We never make the hypotenuse negative. It's either the x or the y coordinate or both that could be negative. That is the end. Have yourself a great night.